Hey, hi, Mr. Tim. Hey, you're drinking wine. Hey, and you look very upset. What happened?
Something happened. I'm just trying to find a solution to my problems.
Oh, actually, chemically speaking, an alcohol is a solution.
Mr. Long, no helping.
So, Mr. Tim, can you share with us why is there wine in our class today?
Well, don't you know, Mr. Long? Wine contains phenols and also alcohols.
Oh, so that is actually the focus of our lesson today, right? We are looking out for organic molecules, specifically with this OH group over here, or in other words, we call this a hydroxyl group. So in our syllabus over here, there's going to be two functional groups that contains this OH group, first of which is called an alcohol, the second of which is going to be called a phenol. Now, today's lesson, we're going to focus more on the alcohol part. And what is an alcohol? We are looking out for this OH directly bonded to a C, and this C must be a saturated carbon. So, Mr. Tim, can you share with me what's a saturated carbon?
Well, saturated carbon means they're all single bonds around it, no double bonds.
That's right. So if you take a look at this person, is attached to this carbon without any multiple bonds there, right? Now, for phenol, it is just having an OH directly bonded to a benzene, and this we are not going to focus on today's lesson. Later on in the chapter, we'll talk about that. So, Mr. Tim, can you run us through some of the classifications of an alcohol?
Yeah, of course. Yeah. So in alcohols, we have three classifications. The first one that we have is a primary alcohol. And again, what's a primary alcohol? Box up the carbon that's holding your hydroxyl functional group. Now, Mr. Long, how many R groups do you see attached to that carbon?
So this carbon only has one R group.
Yes, and we call it primary, right? Now, if there are two R groups, Mr. Long?
Then you will call it secondary.
And lastly, if there are three R groups, we call it tertiary.
That's right.
Yep.
So what happens if there's more than one OH directly bonded to the carbon, Mr.
But then
Tim?
this is a little bit different. So this is where we call it germinal alcohol. Now, if there are two OH groups bonded to the same carbon, we call it a germinal diol. Now, Mr. Long, are germinal alcohols stable?
I do not think so.
No, they are not, right? They are not. So they will actually spontaneously eliminate water, and we call this dehydration. So, Mr. Long, do this with me. We're going to circle the water molecule, circle the OH, circle the H. We're going to remove them completely. Now, the additional dangling bond that you see there, can we connect it to the C single bond O? And this is what we have now, an aldehyde, okay? So, long story short, when you have a germinal alcohol, it spontaneously eliminates water to give you a carbonyl compound, in this case, an aldehyde. Wow, Mr. Long, this is a really good bottle of red wine. How much did this cost?
$300.
Wow, $300. So expensive. Why don't we just prepare our own wine in the lab?
Oh, sure.
Yeah.
I'm going to give you 4 methods of preparing alcohols. So let's go into our notes. First of which, we're going to start off with an alkene, right? So we understood from alkenes that typically they're going to undergo a addition reaction where you're going to break a second bond in the pi bond, and you're going to add two things across them. And of course, Mr. Tim, if I want to create an alcohol, what should be added across them?
Yeah, we need water.
Yes, you need a H and an OH over here, right? The OH is going to create a alcohol for me. And of course, from alkenes, there's going to be two different ways. Either you use concentrated sulfuric acid or concentrated phosphoric acid as the catalyst. Now, the second reaction over here is going to be starting off with a halogenal alkane. We saw this in the previous chapter. Mr. Tim, can you remind me again, halogenal alkane, are they nucleophiles or electrophiles?
Well, so the carbon is attached to a very electronegative element, the halogen. So being electronegative, it will pull electrons away from the carbon and makes the carbon delta positive, electron deficient. So
That's right.
Rx, they are electrophilic.
That's right. So we're going to call this a electrophile. And what's going to happen is that in this reaction, I'm going to use a strong base, and this strong base is going to give me my OH minus, which is going to be a classic nucleophile. You are going to attack the electron deficient carbon atom, causing the CX bond to break entirely. And when that happens, you introduce the OH. That is the second way of creating an alcohol.
Yep. Now, in reaction 9.1, something different now. We still can prepare an alcohol, but we're going to prepare it through reduction, more specifically the reduction of carbonyls. Now, this is the first time you're seeing a carbonyl functional group. So a carbonyl functional group is this. It is when you have a C double bond O, when that carbon is bonded to an R group, we call this a carbonyl. Okay? Now, Mr. Long, can you remind me from Sec 4, right? Reduction, is that the gain of hydrogen or the loss of hydrogen?
I believe that is going to be the gain of hydrogen.
It is. So we're going to go to the CO functional group here, and we're going to gain two hydrogens, one on the oxygen and one on the carbon there. All right? And when we do that, yes, you guys can see we have just formed an alcohol. Okay? Now, there are three reducing agents that you have learned or that you will learn, and the first two is this: lithium aluminum hydride in dry ether. The second one, sodium borohydride in ethanol. Now, these two are very new, so it's okay. Now, the last one you've seen this before in alkenes. It is H2 with nickel catalyst. Okay? Now, in reaction 10.4, we're also going to use reduction to prepare alcohols, but we're going to reduce a carboxylic acid now. Okay? So reduction is the gain of hydrogen, but it's also the loss of oxygen. So in this case, the first thing we're going to do is remove the oxygen from that CO functional group, and then we're going to gain two hydrogens on that carbon there. All right? And when we do that, once again, we get our alcohol. Okay? So for this particular reaction, there's only one reducing agent you can use, and that is lithium aluminum hydride in dry ether. Okay? Julia, you want some red wine? Come on, Raylin, do you want some? Oh, why is everyone ignoring me? Raylin? Come on. You're a drinker, I know you are. Come, Jared, look at you. Such a baller. I'm sure you won. Kang Xiang, no. Oh my gosh, so sad.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Oh, Mr. Leong, so sad. I didn't get a reaction from any of them.
It's okay, Mr. Tim. You can get all the reaction that you want from our encyclopedia. Okay, but before moving into the reactions, right, I think we need to ask a very important fundamental question. Is the alcohol a electrophile or a nucleophile? Now, I'm going to give you 5 seconds to think about this. Have an answer in your head, and Mr. Tim, would you like to enlighten us what is the answer?
Well, not too straightforward because alcohols can behave as nucleophiles and also electrophiles. Now, if we focus on the hydroxyl functional group here, we're going to go to the oxygen. Notice how there's a lone pair there. The lone pair makes the oxygen electron rich. Now, hence, the oxygen is actually nucleophilic. If I put a electrophile, so we have learned this in halogenic alkenes, Rx, they are electrophiles. So if I put a halogenic alkane next to it, the oxygen is going to use its lone pair to attack the carbon there and break off that CX bond. Okay? So the alcohol is clearly behaving as a nucleophile here. Now, Mr. Leong, but alcohols can also behave as electrophiles, right?
That's right. Like what Mr. Tim said, O is very electronegative. It is going to acquire a delta minus charge. And as a result, the carbon that's just beside it is just going to be electron deficient. And that is exactly why it is actually a electrophile. Now, in this respect, right, you will notice that, hey, if I look at your COH, your C is electron deficient. Your nucleophile is going to come in to attack the C, causing the COH bond to go and break off. And if I look at this, your COH is acting exactly as an electrophile. So in today's reactions, later you see this in class, one of the jobs for you to do is for every single reaction, think about whether if the alcohol is acting as a nucleophile or an electrophile. And your teacher will answer your questions today. See you in class. Bye.